Hello, and welcome to today's talk on modern technology. Over the past week, we've been talking about simple machines, but rarely in life do we see a simple machine by itself. Usually we see things like the car, or the coffee maker, or even scissors, that represent simple machines working together, sometimes hundreds or even thousands at a time. What we call these are compound machines, which are two or more simple machines working together. For example, the scissors. Simple, yet shows two machines working together. The first is the lever, because it has a fulcrum, which it rotates around, a side where you put effort, and then the side that does the work. And then on the side that does the work, you also have a wedge, a thin side that cuts, and the other side. So here we have a wedge and a lever working together. Now, to look at the mechanical advantage of compound machines, you simply have to take the product of all the simple machines involved. So let's look at this example that has an inclined plane and a pulley system. Well, let's suppose that this inclined plane has a mechanical advantage of 3, and the pulley system has a mechanical advantage of 4. In order to get the compound machine's mechanical advantage, you would take the product of all the ones involved. So that is 3 for the inclined plane times 4 for the pulleys. So the mechanical advantage of this compound machine is 12. And again, you don't need units for mechanical advantage. Now let's look at another example. Let's say you combine a pulley with a mechanical advantage of 2 and a wheel and axle with a mechanical advantage of 4. What is the compound machine's mechanical advantage? I'll give you 10 seconds to solve it on your own, and then I'll check in with you. Alright, so hopefully you took the product of these two simple machines, which is 2 times 4, to get 8. So if you combined this pulley system and this wheel and axle, you would have a mechanical advantage of 8. The mechanical advantage of combining gears together is a little bit different, and gears are basically wheels and axles with teeth on them. So the mechanical advantage of gears working together is the number of teeth on the driven gear divided by the number of teeth on the driver gear. By driver, we mean which one moves first, and the driven one is the one that was moved because of the other one. So in this case, let's take your bicycle, where you have the pedal gear, the one you pedal, with 30 teeth. And when you pedal that, it rotates, it moves the chain back, which causes the back one to rotate, and thereby move your wheel. Well, the one that you move, the driver gear, has 30 teeth. So mechanical advantage equals 30 goes on the bottom, because that's your driver gear, the one you move, and the one that's driven is the smaller one in the back that has 15 teeth. So the driven gear goes on top. So this case, 15 divided by 30 is 1/2. So the mechanical advantage of this bicycle is 1/2. Now you might be asking, why do we want a machine that has a mechanical advantage of less than 1? Well, although moving the big gear that moves to the small gear will indeed have less power, it will make the small gear move faster. So if you were bicycling, you would want to go from a big gear to a small gear in order to move faster. This would be a good use if you're going down a hill, because you don't need much strength, but you want speed. Now let's look at an example where you go from a small gear to a big gear. In this case, you're going from a driving gear of 9 teeth. So this smaller gear turns, which causes your big wheel to turn. So the mechanical advantage is again the driven gear on top, in this case 36 teeth, divided by the driver gear, which in this case is 9 teeth. And 36 divided by 9 is 4. So the mechanical advantage of this compound machine is 4. Now, when is a case when you'd want to go from a little gear to a big gear? Well, this increases your power, as we can see with a mechanical advantage of 4. But you're not going to go very fast, because for every rotation this wheel has, this one only has 1/4 of a rotation. So when would you want to go slow but have more power? Up hills. Usually when biking, you'll switch into a smaller gear so that it's less work for you, and yes, you will move slower, but it's easier. And usually when you're going up a hill, you're not trying to go fast, you're just trying to make it. So in review, you use a big gear going to a small gear in order to go fast when you don't need as much power, and you use a small gear going to a big gear when you don't want to go very fast, but you need more power. The last thing I'm going to send you off with today on modern technology is nanotechnology and robots. Nanotechnology is technology that's developed by combining molecules or atoms. So it's at a microscopic level. This can be incredibly useful in medical fields and industries all over the world, because these are tiny particles that can fit inside your body and even attack viruses. I would like you to go research 3 uses of nanotechnology today. The other topic you must investigate is robots. Now, robots are advantageous because they can go where people can't, like on missions to Mars, and they can do hazardous work that we can't. So go and investigate 3 uses for robots in today's world. Thank you for watching. Have a great day.